Welcome everyone. Just now we learned the logical and bitwise AND operators. Now let's talk about the OR operators, the logical OR and bitwise OR operators. So you could also use the OR operator to combine two Boolean expressions. And the OR operator, when you use one of those OR operators, it is going to return you a Boolean value of either true or false. Okay. And here's the truth table for the OR operator. If you have two Boolean expressions, if both of them are false, that's the only time that this OR operator will return you false. But as long as one of the expression or both expressions are true, then you will end up getting true when you use the OR operator. Doesn't matter if you use the bitwise or the logical OR operator. As long as one of the Boolean expression is true, then you will always get true at the end. So there are 75% chances that you will get true result when you are using the logical OR operator. When you are using the logical or bitwise OR operators. Okay. And you should also know the difference between the logical OR and bitwise OR operators. So the logical OR operator, it supports the short circuit evaluations like the logical AND operator does. Okay. So for example, when we talked about the logical AND operator's short circuit evaluation, we stated that if the first expression is false, the logical when you are using the logical AND operator, then the compiler does not need to evaluate the second expression. It would just return you false, right? And when it comes to logical OR operator, if the first expression is true, then there wouldn't be a need to evaluate the second expression. Okay, it will just return you true immediately. So that's the short circuit evaluation of the logical OR operator. Okay, but the bitwise OR operator, it always evaluates both operands before returning you the true or false result. Okay. So which means if I have first expression if I have a two Boolean expression and first expression is already evaluated to true, and if I'm using this bitwise OR operator, then it still has to evaluate the second expression before returning true. Even though the final result is already destined to be true, but it still has to evaluate the second expression because this bitwise OR operator, it does not support the short circuit evaluation. Okay, let's take a look at those examples here. In this example, in the first print statement that we have here, the first expression is true and second expression is also true, and we are using this bitwise AND operator. Since both expressions are true, it will return me true. Okay. Since I'm using bitwise AND operator, after first expression is evaluated to true, the compiler still has to evaluate the second Boolean expression. Okay? And if you look at the logical OR operator in the second print statement, so when the num is 0, first expression is evaluated to true. And since we are using logical OR operator, compiler does not need to evaluate the second expression if the first expression is already true, because final result is going to be true. So this is short circuit evaluation. And in the third statement here, num equal to 0, this expression is also evaluated to true. Since first one is true and I'm using this logical OR operator, then final result will be true and it's not going to evaluate the second expression. If I was using bitwise OR operator, even though the final result is going to be true, it would still need to evaluate the second expression in that case. Okay? So this logical OR operator, it operates faster than the bitwise OR operator, since it supports the short circuit evaluation. Okay? And of course, when both expressions are false, if you look at this print statement, 0 equal to 2 is false. 0 greater than 1 is also false. If both expressions are false, that's the only time that you will end up getting false at the end. Okay. And even when you are using this logical OR operator, if the first expression is false, then yes, it will still evaluate the second expression because there's a chance that you could still get true at the end. Okay. In order for a logical OR operator to return true, only one expression needs to be true based on this truth table of the OR operator. Which means when we use this OR operator to create our conditions in the conditional statements, we could use it to create the expressions like either, okay? Either this or that, you know? So because either means as long as one of them is matched, right? Either means one of them has to be matched in order to return true at the end. Okay. Now let's also do some more practice with this logical OR operator and with this bitwise OR operator. Please create a new class under the package module 13 operators part 3 and name your class OR operator. Okay. Let me give you a couple examples of the logical OR and bitwise OR operator to see the difference. Suppose that here we have this int variable x which is equal to 50 now. And if I'm giving those two Boolean expression by using the bitwise OR operator. My first expression, Boolean expression here is x is less than 100. And second Boolean expression is x is greater than 0. Okay? So let's take a look at it now. The first expression that we have here is x, which is 50, 50 less than 100. 50 less than 100 is evaluated to true because it is less than 100, right? If the first expression is true, what will be the result of using the OR operator? If you look at the truth table, if the first expression is true, you will always end up getting true regardless of the second expression, right? Which means the final result is going to be true if you are using the OR operator to if you are using the OR operator with those two operand and first one is already evaluated to true. But since I'm using the bitwise OR operator instead of the logical OR operator, that means the compiler still has to evaluate the second expression, even though the final result is already determined by this first expression. Okay, so compiler will still has to evaluate the second expression, and x greater than 0, it will give me true as well. Okay, so the final result at the end is going to be true. Okay, and if I was using the logical OR operator, let me give the same statement here with the logical OR operator. This is our logical OR operator. What happens is that if the first expression is already evaluated to true, it will just returns me the final result without evaluating the second expression. So there's no need to evaluate the second expression for the compiler. Okay, then it will return us true at the end. So that's the only difference between the bitwise OR and the logical OR operators when you are using them with two Boolean expressions. Okay. Now, when you use the OR operators, the only time that you would get false would be when both expressions are false. If the two operands that you give are evaluated to false, that's the only time that the OR operator will return you false. For example, here, if I for the first expression, if I give x is greater than 200, which is false, right? Or x is less than 0, which is also false. So our x value is still 50. 50 is greater than 200 is false, right? If the first expression is already evaluated to false, this OR operator, it still has to evaluate the second expression because if you look at the truth table, first expression false doesn't mean that final value will be false because there is still chance that the final value could be true, even if the first expression is false. If the first expression is false and second expression is also false, then I will get false. Otherwise, if the second expression is true, then our final value is going to be true at the end. Okay, so since this first expression is false, this oral since the first expression is false, compiler still needs to evaluate the second expression before returning the final value, right? Because final value could still be true. And the second expression that we have here is 50 less than 0, which is false. So if both expressions are false, then yes, you will end up getting false at the end. Okay? Doesn't matter if you use this logical OR operator or if you use this bitwise OR operator, as long as both expressions are false, then you will have false at the end. Okay? So this is how the OR operator works in Java. Thank you so much, everyone. See you all in the next video.